Hello, this is Ahmed Awad. In this video, I'm gonna show you how to use distributive property to factor polynomial. In this video, we have two objectives. Number one, use distributive property to factor. Number two, factor by grouping. Let's see the first objective. We have used distributive property to multiply a monomial by polynomial. You can work backward to express a polynomial as the product of a monomial factor and polynomial factor. As you know, we learned before how to get the product of this expression if we have 2x multiply 3x plus 5. So we distribute, means we multiply the element outside the bracket by the element inside the bracket. So here when we multiply 2x by 3x, we get 6x to the power of 2, and when we multiply 2x by 5, we get 10x. Now, let's use distributive property to factor. Example number 1, 27y to the power of 2 plus 18y. First step is to get the greatest common factor between the two terms of this polynomial. Let's remember how to get the greatest common factor between them. First step is to factorize each term. Write it as the product of its prime factor. 27y to the power of 2, it's equal the product of 3 multiply 3 multiply 3 multiply y multiply y. And 18y can be written as 2 multiply 3 multiply 3 multiply y. Now, to get the greatest common factor between these two terms, we determine how many common factors between them. The 3 common factors between them. So write it as 1 time 3 multiply 3 multiply y. Now, the greatest common factor, it will be 9y. Step number 2 is to write each term of this polynomial as the product of 9y, the greatest common factor, and the remaining factor. What it means? 27y to the power of 2. It can be written as 9y multiply 3y. So the greatest common factor is 9y and the remaining factor is 3y. And 18y can be written as 9y which multiply 2. Third step is to take off the common factors between the two terms now, which is 9y, and write the rest as a monomial. So the rest is what? Is 3y plus 2. We take off 9y and write it as 1 time outside the bracket, and inside the bracket we write the remaining factor. Another example, negative 4 a to the power of 2b minus 8a b to the power of 2 plus 2ab. Let's do it by easy way. Let's deal only with the numbers 4 and 8 and 2. 4 can be written as the product of 2 multiply 2. 8 can be written as the product of 2 multiply 2 multiply 2. 2 is 2. So the common factor between these three numbers is 2. Now, what about the letters? In the first term, we have a to the power of 2, b. And in the second one, we have a, b to the power of 2. And in the third one, we have a, b. To make it easy, take the lowest power of each letter. So here the lowest power for A is A to the power of 1, which is A. And lowest power for B is B to the power of 1, which is B. So the greatest common factor will be 2AB. Now, let's do as we did in the first example. Let's write the three terms of this polynomial as the product of 2A and the remaining factor. The first term, which is negative 4A to the power of 2B, can be written as 2AB multiply negative 2A. And the second term, negative 8AB to the power of 2, can be written as the product of 2AB and negative 4B. And the third term, 2AB, can be written as 2AB multiply what? Multiply 1. The remaining factor here is 1 because the greatest common factor is the same as the term. Now, last step is to write the greatest common factor as one time outside a bracket and all the remaining factors write it inside the bracket. So the first term, the remaining factor is negative 2A minus 4B plus 1. To check your answer, you use distributive property and you will get the first trinomial. Here, if we multiply 2AB, let's do it. If we multiply 2AB by negative 2A, we get negative 4A squared B. And if we multiply 2AB by negative 4B, we will get negative 8AB to the power of 2. And if we multiply 2AB by 1, we get itself 2AB. So we are right. Now, let's move to the second objective of our lesson, which is use distributive property to factor polynomial with 4 more terms. It's called factor by grouping because terms are put in group and then factored. The distributive property is then applied to a common binomial factor. What it means? It means that we have a polynomial consisted of 4 terms, for example, and there's no common factor between the 4 terms, but we have a common factor between 2 terms, and the other 2 terms, there's another common factor between them. In this case, we will group each 2 terms together and take off the common factor, and then we will get another common factor between the 2 groups and take it off. You are confused? Let's see how we do it. Okay, let's solve this question. Example number 1, factor by grouping 4AB plus 8B plus 3A plus 6. If you focus on the 4 terms of this polynomial, you will find that the first 2 terms have a common factor, which is B and 4. And the third and the fourth terms have also a common factor, which is 3. Now, let's group the terms with a common factor. For AB plus 8B and 3A plus 6. Now, let's take off the common factor of each group. The first one, the common factor or the greatest common factor between 4 and 8 as we did before is 4. And for the letter A is not common b is common, so I will take off b. Now, what is the remaining factor? It's a plus 2. Now, what about the second group? Second group, the greatest common factor between 3 and 6 is 3. And what about the letters? There's no common letters. So I will write a plus the remaining factor here is what? Is 2. Always, you can check your answer step by step by using distributive property. If we multiply 4ab by a, we get 4ab. And if we multiply 4b by 2, we get 8b. And here, same. If we multiply 3 by a plus 2, we get 3a plus 6. What we get now? Yes, we get another common factor, which is a plus 2 and a plus 2. So we will take off again the common factor. So the greatest common factor now, a plus 2, we will take it and write it one time, a plus 2. When we take this, as we always do, we write the remaining factor between brackets. So we get now 4b plus 3. 4b plus 3 are the remaining factor. Okay, can we check our solution? Yes, we can. How? By using the FOIL method. You remember the FOIL method? Which is first multiply first, outer multiply outer, inner multiply inner, last multiply last. If we multiply here 4a by 4b, we get 4ab. If we multiply a by 3, we get 3a. If we multiply 2 by 4b, we get 8b. And if we multiply 2 by 3, we get 6. The same terms, but not in the same order. 4ab, 4ab, 8b, 8b, 3a, 3a, and 6, 6. So we are right. Example number 2. 2x squared y minus 15 minus 6x squared plus 5y. In this example, you can see that there is no common factor between 2x squared y minus 15 and no common factor between negative 6x squared plus 5y. But we have a common factor here between negative 6x to the power of 2 and 2x squared y. And also we have a common factor between negative 15 and 5y. So we will do initial step, which is reorder the terms of this polynomial before grouping the terms which have a common factor. So let's do it. So it will be equal to x to the power of 2y minus 6x to the power of 2 minus 15 plus 5y. Now let's group 2x squared y minus 6x to the power of 2 and plus negative 15 plus 5y. Now, it's become easier for you after 4 examples to get the common factor between these two terms. Now, here, the greatest common factor between these two terms is what? Is 2 of the numerical term and x squared, the algebraic term, and the remainder is y minus 3. The common factor between negative 15 and 5y is 5, and the remainder is negative 3 plus y. Now, is there a common factor again? Yes, which is y minus 3. Remember, addition is commutative, so we can write it as 5 multiplied y minus 3 is same as negative 3 plus y. Let's write the first term again. 2x squared multiply y minus 3. So we have y minus 3 as a common factor. Let's write it one time. So we will get y minus 3 multiply the remaining factor, which are 2x to the power of 2 plus 5. And always remember, we can use distributive property and FOIL method to check our solution. Now, you are ready to check your understanding using this example. You can find it in your book, page 523. Thank you for listening.